All right, like I said, I'm new to doing things on YouTube, so I'm trying to figure this out, and I'm using a bad system. I think I can only record videos up to 15 minutes long, so we'll uh, we'll work on that, and I'll try to figure that out going forward. But just going back to where we left off in part one of this video series, um, we were talking about this idea of space-based geometry. Um, we talked a little bit about how it's a little bit smaller in size, and we compared that to integers and positive integers and things of that sort. So basically, what we what we have here is a geometry that we're starting to manipulate a little bit more than just based on this idea of a Euclidean or quote normal geometry. So that's the basic idea of this space-based geometry. Is it's a little bit different than what we're used to, what we might say makes sense in a way, even though it all makes sense once you start to really look at it and understand it. But when it was first being used, probably what most people would say makes sense. So, anyways, now we're going to move on to something that's a little bit more outside my pay grade. So, this is probably where future videos would be more helpful. But what we really want to do here is kind of look just generally and very basically of how geometry has gone after this idea of okay, maybe geometry isn't just Euclidean, maybe it isn't just this idea of normal geometry or whatever we want to call it. So, um, so once we get a good idea of this idea of a space-based geometry, we start to see a new approach to geometry. So this approach is that of groups, or a more localized idea of geometry. So a lot of this makes a little bit more sense when we start to see who had a big impact on this part of geometry. And a key contributor was Riemann. So depending on how far you've gotten in your math classes, you've probably heard the word Riemann or the name Riemann, heard the phrase Riemann sums. So this idea often involves taking an n amount of terms in a group or n amount of groups and trying to get a final idea or collection of numbers or information. So basically, what he did was find a way to group different information in a geometry that sums up all the information to get an idea of what we know or what we can understand from what we've seen or been shown. So this work by Riemann really was important and led to this next idea of topology. So the idea of topology allows us to put together different groups into a single space. And these ideas really come from an idea of a manifold. So I don't fully understand what a manifold is myself. I've asked a few people and gotten a few things, a few different ideas, but I still don't fully comprehend what it is. So make a note. You're going to want to look up manifolds. They're really important in topology, and topology is important to the study of geometry. But generally speaking, a manifold, from what I can gather, is a curved space with properties that extend beyond those of just Euclidean geometry. So um, there's really a large amount of great sources you can look to. I've listened to a few great podcasts about topology recently, so there's a lot of those. So if you're really interested in this idea of a manifold, you'll definitely want to check those out. But the from just a few of the sources that I've looked at and things I've gathered, we can kind of just compare this idea of topology and manifolds and everything to just this common joke that mathematicians typically hear. I guess I don't know how I want to describe that, but It goes along the lines of a topologist is a man who doesn't know the difference between a coffee cup and a donut. So this just comes from a basic topological idea that shapes and spaces can be deformed or reshaped into another shape. So I have this picture up here in the top right, if you're watching still, that shows all these ideas they're all basically the same thing from a topological view, um, and that comes from they all have a single hole, and they've all just been reshaped and deformed to look different ways, but they all have the same basic idea. So that's where this joke really comes from, because coffee cup has the hole for the handle on the mug, the donut has the hole just in the middle. So it's this idea that you can deform these different shapes and form different shapes from them. So yeah, so there's a lot of things that we could dive into with that, and just in general with this idea of progression of geometry. But I thought these were the top 5 things that would really appeal to uh, a general audience, and they really do give a good idea of what geometry is, and a good idea of the history of geometry itself. So again, feel free to look more up if you find some great things that I missed about the history. Feel free to include it in the comments, and I can take a look at it and potentially make another video to go along with this one. So we'll just move forward though. So I guess the next topic I really wanted to dive into is, why do we study geometry? So I think we can all agree that geometry is fundamental to how the world works. I mean, if you're not quite sure about that, just take 5 minutes and think about how shapes and objects interact with each other every single day. These interactions are undeniable, and if you really make a conscious effort to think about them, you'll see them. You can't miss it. So just think about it as you go throughout the rest of this week. Think about how geometry plays a big part in your life, and how these different shapes and ideas influence everything you do. So yeah, once you start looking for it, you can't unsee it. You're going to see it everywhere. And not only does geometry intermingle with everything that we do every single day, but it also interacts with math in every single way as well, which, I mean, it's pretty undeniable that math plays an important role in everyday life as well. That one might be a little bit harder for you to see, but it definitely plays a part in everything that we do every single day. So I guess just going along with that, I mean, where do we see geometry? So just from the math side of things, we see geometry in every single discipline, every single part of math. But just want to focus on a few of the big ones that I think are important. So this idea of geometry and trigonometry, I mean, trig is basically the study of the computational side of geometry. It's basically how shapes relate to each other, and how their measures relate to each other, and how we can compute these different ideas and relationships. It also plays a big part in calculus. Calculus is a very geometrically based subject. Like I mentioned, it played an important role geometry played an important role in the development of calculus itself, and we'll talk a little bit more about that a little bit later. But something that's really interesting too is some of the most basic geometric ideas from these early geometers like Pythagoras and Euclid and people like them. Their ideas can be created based on just calculus alone. We don't even need the shapes per se, but we can just do the computational calculus. There's actually an incredible website that I found that talks about the major developments in geometry, early geometry, and then it shows how if Newton or whoever had came before those people, he could have done the same things just based off of what he learned and found out. So I'll be sure to attach that into the description of this video so you guys can go take a look at that. but um, but yeah, I mean, I could spend a whole video about how geometry impacts calculus, but I I really think that's a good one for you to look up on your own as well. But everything in calculus relies on geometry for the most part in some way or another, and it's just interesting to see that calculus can rederive these different ideas of geometric ideas as well. um, Another place where we see geometry a lot is in linear algebra. So I feel like there's a lot of people out there that hate or dislike strongly linear algebra. I've heard a lot of people recently talk about that. But there are a lot of incredible and really cool things that you can do in linear algebra. That was the subject that really solidified my enjoyment and love for mathematics. It's really interesting to me all the different connections that can be made between linear algebra and different subjects throughout mathematics, and just within itself there's a lot of different things that connect to each other. But anyways, um, a big part of linear algebra is systems of equations. This idea of systems, well, I feel like we've heard that word before here. Systems, oh yeah, that's right. Systems are where geometry really became formalized. I mean, if you think about what geometry really is, it's a bunch of systems. So if we think about linear algebra, it's kind of like understanding relationships of systems and understanding how they relate to one another. And so, I mean, just looking at that alone, it helps to see, oh, yeah, there's a geometric side to this. And there's a ton of other connections there. Linear algebra focuses a lot on dimensional systems, and we can apply that to geometry as well. So there's a lot of connections there as well. And like we mentioned, topology is basically a geometry based subject. So there's a lot of connections to that as well. We've kind of touched on already. But these are just a few places and a few different disciplines we see geometry in math, but nowhere near a comprehensive list. So again, you can look that up, figure that out for yourself where else you might see it. But just a few places where we see these ideas of geometry and other mathematic relationships come together. Just really briefly, is in our everyday lives we see that they play a part in understanding spatial relationships and construction and the creation of different things. It's in entertainment, it's in clothing, it's in all these different things. Maps rely heavily on geometry and the math inside of geometry. So, I mean, we see geometry everywhere, but this is just a few basic ideas of where we see it. So,